And because of the anti-Pythagorean feeling in Croton, he fled that city. Is it Croton? Crouton? I don't know what it is. It didn't sound right the way I was saying it.
Hi, my name is Richard Dix, and this is How Did That Happen? A podcast where I look at everyday things or events and try to figure out how they came to be. Every week I will research one topic, and by the end of the episode, I hope to truly have the answer to the question, how did that happen?
Hello, and welcome to another episode of How Did That Happen? HDTH. This week we are discussing right angles. Come along for the ride this week as I ask, right angles. How did that happen? All right. Welcome back to another episode, HDTH, episode 38. This time we are talking about right angles. This was an episode that I already envisioned doing a long time ago, but almost basically had to kind of figure out the format of the show before I could even attack some of these. And you'll see some of these as we do more episodes now. There is a whole section of lists. I had a list of, when I first started this podcast, I had a list of topics I wanted to kind of get through to kind of try to lay the base of what the podcast could be. And then I have a whole nother list that I haven't even touched yet. This one isn't one, but it's kind of getting into that idea is others kind of just where their podcast is on the way to. And so this is almost a bridge, if you will, one of these episodes where it's just like I knew 6 months ago I wanted to do an episode on right angles, but I just didn't know enough about what this was to even do that. So before we even get to the episode, I do have a little bit of housekeeping I want to get out of the way. We have another 5-star review, and this one is coming from Apple Podcasts. I know some of you might be saying, "Well, I'm not on Apple Podcasts. How can I?" I'll take a review anywhere you want to put it, man. If you want to write it on the stall of a bathroom, door, I don't care. Let them know that you love finding out how things happen on HDTH every Monday at 4:30 a.m. So this one comes from what's called their name is Podcast Beauty, and they say 5 stars, very interesting and entertaining. Richard presents the content in an easy format and makes learning the new facts fun! Exclamation point. Highly recommend this podcast if you're a history and info enthusiast. Once again, exclamation point. And all the best to you, third time exclamation point, Yvette Podcast Beauty. I appreciate it. I really do. Every review helps. If they're 5 stars, they're even better. If you don't want to leave it 5 stars, leave me a 3-star. Leave me a 2 stars with some constructive criticism. I'm open. I really am. I don't mind. I know this is not all perfect sunshine and roses, so I'll take whatever you can give. And if this is what you can give and that is nothing, then keep on giving, brother. I'm serious. So let's see. One more thing before we get out of here and start the episode. What am I reading right now? I'll be honest, not too much. I'm still in the same place with those books, but I'll tell you what I have been watching. I have been watching these British true crime drama mystery shows that they just suck you in. I just finished one called The Vigil, or is it Vigil? About, I think it's the Scottish nuclear submarines. And I'm watching one right now called Smother. And that is about an Irish family, just a rich Irish family who's got a bunch of crazy stuff in their closets. And it's like, who's going to do what type thing. I'm always a sucker for those kind of shows. Let's see. I'm also watching The Resort on Peacock. That's a really crazy show. Don't really know if I have enough time to go into the whole thing, but if you're looking for a little bit of an oddity to just kind of take your time up and get your mind off some things, that is definitely a show that I would recommend. Is there anything else I want to get off my chest before we start telling you guys about right angles? I don't think so. Still loving the activity on the Twitter page. Every day we are one step closer to doing video and a website. I know I say that seems like every episode, but one of these days, guys, you'll see my face and there'll be a whole .com where you can go and find out how things happen. But until then, here's the episode. So the meaning of right in right angles could possibly refer to the Latin adjective rectus, which means straight, erect, or upright. And in geometry and trigonometry, a right angle is an angle of exactly 90 degrees or radians corresponding to a quarter turn. So right angles are everywhere. Everywhere you look, you see right angles. Even if you don't believe it or even if you don't recognize it or not, it can be anywhere from your coffee table to the roads in your city. A triangle that has a right angle is also known as a right triangle, and so to which you can apply these special properties such as the Pythagorean theorem, and that's what really makes a triangle a right triangle. But we'll get into that. And so right angles are important to recognize and understand since they're used everywhere, anywhere from like I said, geometry to trigonometry to real life applications. But in order to really get to the heart of these right angles, we have to go back, as we normally do, back into time. And start with our good old friends, the Babylonians. We'll start with Babylonian trigonometry. And so the Babylonians discovered their own unique form of trigonometry during the Old Babylonian period, which was from 1900 BC to 1600 BC, and which was more than 1500 years before the Greeks ever got around to doing what they were doing. So remarkably, their trigonometry contains none of the hallmarks of our modern trigonometry. It does not use angles, and it does not use approximation. And we're going to get to this. The next part explains it more, but we've talked about it a little bit, I think, before. We talked about the idea of time and the creation of time, and how really the 60-minute and like 1 hour clock and 60-second minute are all come from Babylonian math, because they did math differently than what we did, and it's a carryover from basically when people did math differently than what we did, but we brought that into our life. That's a different podcast episode that I've already done. I'm not 100% sure which episode number it is, but it is about time, and we do mention that. But let's get to the Babylonians and their measuring system. So the Babylonians had a completely different conceptualization of a right angle. As we said, they saw it as half of a rectangle, which is already different, just to begin with. And due to their sophisticated sexagesimal number system, which is like I mentioned before, it's based on 60 and not like how we do out of tens. They were able to construct a wide variety of right triangles using only exact ratios. And so it's interesting, just from the perspective, like when I was reading about this, to know that, when you look at it, you think the way that we learned is the only way that you can learn. And you think, and so it's like when they made the new math now, which I still have not done. I don't know anything about it. I don't have kids, but I hear about it, and evidently it's different than, what we in our generations grew up with, but it's like all getting to the same answer. It's almost the same thing with this. It's like they were able to, it's not new, it's old, it was the first, but they're able to get to the same answer. And so you don't always have to have the same instruction or ideas to get to the same goal. I guess it's the same endpoint. But that sounds like a topic for a whole nother day. So we get to the Plimpton 322 tablet. And so we now know that the Babylonians studied trigonometry because we have a fragment of one of their trigonometric tables. Trigonometric. Man. Plimpton 322 is a broken clay tablet from the ancient city of Larsa, pretty cool name, which was located near, Telasankara. Man, they don't make this stuff easy. Which is in modern day Iraq. So the tablet was written between 1822 and 1762 BC, which is right, if you remember what I said just a little bit earlier, is right in the time of when the Babylonians were creating this trigonometric, or this trigonometry that was based on the sexagesimal number system. And so in the 1920s, the archaeologist, academic, and adventurer Edgar J. Banks sold the tablet to the American publisher and philanthropist George Arthur Plimpton, and that's where we get its namesake. So before that, it was just the tablet, or maybe it was the Banks tablet, or whatever, but the actual name of it is the Plimpton tablet. Is because a guy named George Arthur Plimpton, initials GAP, G-A-P, was the guy who actually bought it. And so Plimpton bequeathed his entire collection of mathematical artifacts to Columbia University in 1936. And it resides there today in the Rare Book and Manuscript Library. And so what I have here in my notes is, at the same time as this was happening, there was another clay tablet that was excavated some 350 kilometers from the city of Babylon, which kind of shed more light onto the Plimpton tablet itself, but it wouldn't actually be translated for another 15 years or so. And so when it was translated, the text provided confirmation that the Babylonians measured angles using the figure of 360 to form a circle, and the inscription on the tablet shows the ratio of a perimeter of a regular hexagon to the circumscribed circle, i.e. the 6 sides of a hectagon times their base of 60 equals 360. So, and say all that to say, just they really did have a different way of looking at math and numbers, and theirs was also successful too. It just got lost, to time, basically. And so the Babylonian approach is also much simpler because it only uses exact ratios. There are no irrational numbers and no angles. And this means that there is also no sine, cosines, or tangents for approximation, which is basically, you don't want to say it makes their math a little bit better, but I mean, it's almost like we have the math we have based off of where we are in the timeline, because it's like we have calculators and endless papers, so we can do math that has just like repeating numbers and constant things you have to do, all these different sine, cosine. When I learned that in school, it was hard. It wasn't easy. But the Babylonians were just like, no, we use this type of number system, and this means we don't have to have all these created numbers, or numbers that just go on for infinity. Pi 3.14 didn't exist to them because they just added up numbers differently, and it's interesting. The Babylonians did discover a method of finding Pythagorean triples, that is sets of three whole numbers such that the square of one of them is the sum of the squares of the other two. So they, in a roundabout way, found their way to the Pythagorean theorem, which of course they did not call it that because old Pythagoras wasn't even alive at that time. The first known instrument for measuring angles was possibly the Egyptian groma. Probably not pronounced that way, but it was asking to be pronounced that way. Groma, which was an instrument used in the construction of massive works such as the pyramids. So that would have been the first time that we really have real concrete evidence of someone trying to work right angles into some construction. Besides the Babylonians, which the stuff from Babylon is always so hard to come across that while we know in certain cases what they did, we don't always have proof of the things that they did. So the groma consisted of 4 stones hanging by cords from sticks set at right angles, and measurements were then taken by the visual alignment of 2 of the suspended cords and the point to be set out. And it was rather limited in its application due to the fact that it was only able to be used on a fairly flat terrain, and its accuracy was limited by distance. So, I mean, it was something early, on in the technology, but it was still providing the same product of the right angles. It was just, you really could only do it under certain circumstances. That brings us to the rule 345. And I thought I would jump to this one, or not jump to this one, but put this one before actually explaining Pythagorean and Pythagoras and all that stuff, because this to me goes more with the Babylonian idea of you don't need all this technology and stuff like that to ensure that your right angles are correct or anything like that. There are people who do this stuff without having to do any of that, and that's what this rule of 3, 4, and 5 is about to teach us. Throughout history, carpenters and masons have known a quick way to confirm if an angle is a true right angle. It is based on the most widely known Pythagorean triple, which we just mentioned the Babylonians discovered themselves, the 3, 4, and 5, and it's so called that rule 3, 4, 5. So from the angle in question, running a straight line along one side exactly 3 units in length, and along the second side exactly 4 units in length, will create a hypotenuse, which is the longer line opposite the right angle, that connects 2 measured endpoints, and if this is going to be exactly 5 units in length. And so when you see that, that means that it is in fact a right angle. This measurement can be made quickly and without technical instruments. So that's why I thought this, that it's, because I feel like the Pythagorean theorem, while effective, and it is effective, there's no but to it, but it's like there were people who did this before who didn't have, they found a way to do it without all of this extra stuff. So the geometric law behind the measurement in the Pythagorean theorem, the geometric law behind the measurement is the Pythagorean theorem. It's the idea that the square of the hypotenuse is a right angle, or is a right triangle, which is equal to the sum of the squares of the 2 adjacent sides. We're all talking about the same thing here. And now we get to Pythagoras, our good old friend Pythagoras. Doesn't even sound like a real name. So he was born in Samos, and likely went to Egypt and Babylon as a young man. And he immigrated to southern Italy around 532 BC. Now, hearing the fact that he hung out in Babylon for a little bit is a little bit suspect when you want to talk about all the ideas he quote unquote created. I'm just going to say, I'm put it out there. We're talking, this is like 2,500 years ago. So it's all water under the bridge, and that bridge is probably decayed by now. So he was running away from tyrants, and he established his ethical political academy at Croton. And because of the anti-Pythagorean feeling in Croton, he fled that city. Is it Croton? Croton? I don't know what it is. It didn't sound right the way I was saying it. But he fled that city in 510 BC for Metapontum, which is basically now Metaponto, Italy, where he died. It's okay if you don't understand what I'm saying, because I can barely get these words out myself. The inner circle of his followers, they were known as the Mathematicoi. Which is, I never knew they had, is that like a math gang or something? I don't know. And they usually, for the time, and usually for the time, it included women in its memberships, because chicks can do math too. There was an outer circle called the Acousmatics, which actually sounds kind of a cooler name than the Mathematicois. Imagine them just fighting on the streets like sharks and jets. They lived in their own homes and came into school by day. So they were the kind of guys who were, they were the day campers. It gets around 5 or 6 o'clock and they gotta head on home. But your Mathematicois, they're hardcore. They're staying up all night, doing their times tables, or running their Pythagoras, or you can tell I don't really know what I'm talking about. But the Pythagoras, however, is generally credited with the theory of functional significance of numbers, the theory of the functional significance of numbers in the objective world and in music. But what they actually say, a lot of people say, is that basically the people in his camp, the old Mathematicois and the Acousmatics, which just sounds like a group from the 70s, now playing the acousmatics, and all that stuff. But those guys were the ones who actually created a lot of the ideas that we attribute to